For part 4, we're dealing with quadrature. So they want us to use the composite trapezoid rule to integrate a function. And the formula is given in equation 9. So we can see that we have an h and we have fa over 2 plus fb over 2 and a summation of f's. They have defined h for us, which is equal to b minus a over n, and they have also given us what x sub k is, which is a plus kh. They have also given us code, which is here, to calculate this integral numerically. So they use this equation over here, and this is what this code does. So let's go over the code quickly. So we have our function here. We can see it takes in 4 parameters, one of which is f, which is the function handle, a, which is the left endpoint, b, right endpoint, and n is the number of subintervals. Also, we can see that t here is our output. So we first want to calculate what h is, which is already given, b minus a over n. And then here is a little weird in which we are adding the endpoints. So usually we initialize with 0, but in this case, what we are calculating here is just fa over 2 and fb over 2. So the whole summation, which they call t, is this entire bracket here. So if we initialize this, we can just simply add the summation of f onto this. So there's no need to initialize with 0 if we have this sort of thing here. So the for loop here is just computing the summation, and after that, we just multiply everything by h as stated in this equation over here. So they ask us to look or compute the integral of sine from 0 to pi. So let's just do that in MATLAB. Also, we're using 101 subintervals, and then we can look at how our answer compares to this later. So as you can see, I have my trapezoid rule function here. So let's just open a new script, and let's save this as problem 4. So here we have problem 4, and we're saying it is part A. So let's say part A. So we want to take the integral of sine. So our f function is f equals at x sine of x, sine of x, and we're taking a equal to 0, b equal to pi. Then we're taking n equals to 101. Then we can simply just say t equal trapezoid rule f a b n, and we can display t, capital T. MATLAB is case sensitive, so make sure that the uppercases match. Let's run this and see what we get. So we get 1.999838 something something something. So we can compare that, and it looks about right. So we know that we have inputted this correctly. All right, we can move on to part B now, and they want us to take the integral of arctangent from 0 to 1. And they tell us that the exact integral for the exact value for the integral is in equation 12. So it's pi minus 2 ln 2 over 4. So before we forget about this, let's just type this into MATLAB. We can refer to it later. So moving on to part B, we can say that exact is equal to, pi minus 2 times log 2, and let's just put brackets around that, and what is it, over 4. As a reminder, log in MATLAB is of base e, so it is a natural logarithm. If you want log of base 10, then it's just log 10. But here we want the natural logarithm, so we're just going to delete that. But that's just a little reminder, the difference between base 10 and base e log. All right, let's look at the rest of the question and see what we want to do. All right, so here we have a table that we want to fill out. So in this column, we want to fill out the exact minus our numerical value. So this is what we know as the forward error. Here, we want to do the exact value minus 4 times t sub 2n minus tn over 3. So what this is the value from the next one over. So it's the value from n that is double the previous one. So we can go ahead and type that in. So let's just do that for n equals 10 for now. And before that, we actually need to write in our function. So we want f a tan of x, and then we're integrating from 0 to 1, and we have our exact value here. So t10 is equal to trapezoid rule FAB and 10. And we can do the rest as well, so we can go ahead and copy and paste it a couple of times. I may have done one too many, but we will see. So that's 40 and 80, and this is 160. All right, so we have completed the calculation for T10 to T160. Now let's just calculate this over here since we already have all the T values. So we're calculating everything in the big round brackets here. So we're just going to call that T2N 10. And we're just referring to this again for Tn minus Tn over 3. So 4 times T20 minus T10 over 3. And we can repeat that again. So we can just copy and paste 2, 3. So this would be for 20, 40, 20, 40, 80, 40, 80, 160, and 80. Alright, so let's just double check this is correct. Yes, it is. And we can see that we don't have one for 160. And in the midterm PDF, that this is blocked out because we don't have T, I guess it would be 320 here. So let's go ahead and compute the forward error now. So we can do E10 equal to absolute value of exact minus T10. And once again, we can copy and paste all of this. Whoops, I think I accidentally ran this. And it looks like I spelled trapezoid rule incorrectly, but I'll fix that after I finish this. And 160. So let's go back and fix this. So instead of trapezoid tool, is trapezoid rule. So it helps if you spell everything correctly. All right, and then we can do E2N. So that would be our second column, and we are just subtracting exact and 2n. So the values that we calculated here. Of course, again, we won't have n equals 160, so we don't need that. And this would be 20, 40, and 80. All right, so let's clear the command window and let's run this. So obviously none of this will display in the command window since I have put semicolons here, but we can look in our workspace and see what our answers are. So let's just take a look at E10, and that is 4 times 10 to the minus 4, which is pretty good. and we can compare that to E sub 2n 10. And we can see that this is actually a lot better. So everything else in this question just talks about why this particular part is better than just simply taking Tn. So if you're interested, give it a read. Otherwise, just say you're done with question 4. So thank you for listening to me talk about problem 4 from the 2017 midterm. Please give me some feedback, like whether you like it or not. You can just give me a thumbs up. That would be great. If the response is overwhelmingly positive, then I'll consider doing this for the final. But instead of using MATLAB, we are using, or it will be all theoretical. But anyway, thanks for your patience and good luck tomorrow.